We're going to look at a few quadratic problems that instead of asking for an x or a y in a solution, we're going to be looking at asking for maxes and mins. This one asks for the max area of a rectangle. So I've drawn a rectangle, and if the perimeter, if you think about it, if the perimeter is 100, that means half of the perimeter would be 50. And if that's the case, if I let the width be x, then this is going to be 50 minus x. Okay, so over here when I do step 2, I'm going to let x equal the width and 50 minus x be the length. Now I want to maximize the area, so I'm going to need the area formula. The area formula is A equals length times width. In my case, I've got x times the quantity, 50 minus x. I don't know what the area is, I'm just supposed to maximize it. So think of this as being like your y. I've got y equals 50x minus x squared. So I have 50x minus x squared. Now if I rewrite that, I've got negative x squared plus 50. Alright, this is a quadratic. It's missing the constant term, so it's actually relatively easy to complete the square. I'm going to add a blank and subtract a blank. So if I put this in parentheses and complete the square, I'm first going to have to pull out the minus 1. So I'm going to pull out a minus 1 and I get x squared minus 50x plus blank minus blank. Now to fill in this in the blank here, half of 50 is 25, squared is 625. But I didn't really add 625. This represents a negative 625. So to counteract that, I'm going to have to add 625 out here. So looks like my equation ends up being the following. A equals negative 1 times the quantity x minus 25, quantity squared, plus 625. So the vertex of this parabola is going to be 25, comma, 625. Now, if it's a vertex, and because it started with a negative, I know that my graph is an upside down parabola. And I've actually put in the graph of the parabola right here. So at 25, which would be, right here, I come up to this point, that vertex is going to be 25, comma, 625. So what that tells me, remember that this x over here, this stands for the width of your rectangle. This over here stands for the area. So the y-axis stands for the area. So where is the area the highest? It's the highest at the vertex. So the biggest area you can get is 625 square meters, and it's going to happen when your width is 25. So now I can write my conclusion. Therefore, the maximum area is 625 square meters. So you can see I circled the equation here for my 4 because there's not an actual point that I'm not solving for x equals a number. I actually need to get my answer from this equation, and more specifically from the vertex of the equation. Okay, now I'm looking for two numbers whose sum is 36 and whose product is a maximum. Alright, so first of all, I'm going to let x equal the first number. Then the second number, if their sum is equal to 36, then the second number is going to be 36 minus x. Alright, now, I don't know what the product is, so I'm just going to use p for product. So product equals x times 36 minus x. Now if I write that in standard form, I'm going to get p equals negative 1x squared plus 36x. I'm going to complete the squared, plus blank minus blank. I've got to pull out the negative 1, so I pull out the negative 1 and I get x squared minus 36x plus blank minus blank. Filling in the completed square, I get half of 36, that's 18. 18 squared is 324. So I put that here. That really is a negative 324. So to counteract that, I need to add 324 over here. So my equation is P equals negative 1 times the quantity x minus 18, quantity squared, plus 324. Okay, so if the vertex is at 18, 324, that means, and remember that this is P, this is x. That's my number. So if my number gives me the maximum product when my number is 18, 36 minus my number, 36 minus 18, is also 18. So I'll put a number 4 over here. So if you take a look at the graph, if I graphed it, my vertex would be 18, 324. Remember again that the 18 stands for x, my first number, and the 324 stands for my product. And the 324 is the very highest point on that curve, so that's the maximum product, and it happens when my numbers are 18 and 18. So now I can write my conclusion. Therefore, the maximum product happens when the numbers are 18 and 18. Okay, here's our next problem. Julie has 52 feet of fencing to put around her rectangular garden. If she used the house for one side, how big should she make the dimensions to get the largest area? So we're trying to find the length and width for largest area. And I've got a picture drawn here with the house on one side. So if I let the width be x, so I'll say let x equal the width, then I need to say what the length would be. Now if the width is x, then the length is going to be 52, take away both of the x's, so minus 2x. 52 minus 2x is the length. So now I need my equation. I know that the area is length times width, so I'm going to use A equals x times 52 minus x, minus 2x. Alright, that's my area function. So if I simplify that, multiply through, I'm going to get 52x minus 2x squared. So I'm going to put the minus 2x squared first, and then plus the 52x. What I want to do is find the x that will give me the largest A possible. So in order to find that, I would graph this function and find out what the vertex is. So I need the vertex, and I get that by completing the square. The first thing I need to do is put in my parentheses and my blanks. And then I'm going to, here's my plus blank, and then my minus blank. Now I need to pull out the negative 2 before I do anything else. So pull out the negative 2. Half of this is negative 13 squared is 169. So when I put 169 in this blank, you need to realize that that really stands for a 338, and it's negative. So in order to undo that, I'm going to have to add 338. So that gives me the following equation. A equals negative 2 times the quantity x minus 13, quantity squared, plus 338. Okay, so let's take a look at that graph. Okay, here's the graph, and what I want just to remind you again of is the fact that the x-coordinate here stands for the width of my rectangle, and the vertical axis, the y-axis, that actually stands for my area. So the place that I'm going to get the highest area is at the vertex here. So if you come over here, that's your 338, that's your area. This is my width, this is my x. So when I go to do my conclusion, or my solution actually, I look at my vertex, and looks like I'm going to need to have x equals 13 and 52 minus 2x to be which is 26, to be my other amount for this particular problem. So then I can write my conclusion. Therefore, the width must be 13 feet and the length 26 feet. Alright, here's our last problem. The cost for making pillows is C at x equals 2x squared minus 96x plus 6,837, where x represents a carton of 100 pillows. How many cartons should be made to minimize the cost? Now you can see I've written my find statement, my let statement, and my equation because all of them came directly from the problem. One thing I would like to point out is C at x is just function notation. We're used to seeing f at x or g at x or h at x. We're using the letter C here to stand for cost. On the other problems we could have used a at x for area, but I just chose to use a. Alright, so let's take a look at what we have. I need to take this and I need to complete the square and find my vertex. My vertex is at 24, 5685. So let's see what that means. Alright, I have two graphs here. The smaller one I wanted to put on just so you could get a reference of where that parabola is on the entire xy axis. And then I zoomed in on it so that we could get a little bit closer look at what I have here. My vertex is the point 24, 5685. And remember what that represents. This 24 is the number of cartons, and this is the cost. Now, as a business person, I want to find the spot along this parabola where the cost is the very lowest it can be, which would be right here. Anything else that I produce is going to have a cost that's above that. So to minimize costs, I'm looking for this vertex right here. So now I can go ahead and write my conclusion after I write my solution. Therefore, 24 cartons should be made to minimize cost. Now, just as a closing comment, for your step 4, you can circle the vertex, you can circle your equation that shows the vertex, or you can write x equals 24 for the max, x equals 24, c at x equals 5685. I'm not real picky about what you circle there. If you have your equation, that shows me that you can answer the question in step 5. Okay, there you have it.